It's learning target 2 in our unit on logarithmic functions. The target states I can solve log equations. These are the general steps that you're going to use to solve any kind of log equation. We're going to first write down our equation. We're going to take a look at it and see, does it say log only once or twice? We're going to then condense it down, this make it say log only once, if it does say log more than once. Then once it says log only one time in the problem, we're then going to change its form either from log form into exponential form or from exponential form into log form. That's going to help put the variable in the right spot so that we can solve for it. We can always plug in our answer at the very end into the original problem just to ensure that we got the right answer. So in this problem here, I've written down my equation, log base 5 of x minus 3 equals 2. I take a look at it and I realize it already says log only once in this problem. So I'm not going to actually do anything to the problem for step 2. So step 2 is already done for me. Now it's time to change the form. I'm going to change it from its log form into its exponential form. Its exponential form would have a base 5, an exponent of 2, and on the other side the equal sign would be what's in the parentheses, x minus 3. I can now solve for this. 5 squared is 25, and add 3 to both sides, and my x is equal to 28. Let's plug this into my original problem, just to make sure I got the right answer. So log base 5 of 28 minus 3 equals 2. Log base 5 of 25 equals 2. And you can check this in two different ways. We can check this either by changing its form, or we can check it by doing change base. I'm going to just change its form. Its form would say base 5 exponent 2 equals 25. And yes, I know that's true, so I got the right answer. In our second example, as I start to analyze what the problem says, I notice that it does say log twice on the left side of the equal sign. This is where I need to condense it down to say log only once. The property I'm looking at is product property because there's a plus sign. So I'm going to condense this down into a single log base 3. Since it says plus, that means I take the x and I times it by 81, and it's still equal to 5. Now it's time to change the form. I have base 3 exponent 5 equal to 81x. Start to solve this. Three to the 5th power is 243. Divide both sides by 81. And I end up with a x equal to 3. Let's check our answer to make sure we're correct. Log base 3 of 3 plus log base 3 of 81 is equal to 5. Now log base 3 of 3 is equal to 1, and log base 3 of 81 is equal to 4. Does this equal 5? Yes, it does. So my answer of 3 was correct. Here's one more example where we do see logs happening in two spots on the left side of the equal sign. Let's look for which properties I need to use. First off, I notice there is a minus sign. That means that I'm going to have to put these together by using the quotient property and have a division in my logs. I also notice there is a 2 in front. That means I'm going to be using the power property. That 2 will become an exponent. So now my problem would be log base 2. The 2 becomes the x's exponent. There's a division sign because of the minus sign, so for quotient, and then the 4 underneath because it comes with the second log base 2. This is still equal to 2. Now it's time to change the form. I have a big base 2 now and an exponent of 2 from the right side of the equal sign, and it will be equal to my x squared over 4. Let's start to solve this. 4 equals x squared over 4 times both sides by 4. X squared is equal to 16. Square root both sides, and I get an answer of 4. Let's try plugging this back into my original problem. So 2 times log base 2 of 4 minus log base 2 of 4 again is equal to 2. Log base 2 of 4 is equal to 2. So my problem now says 2 times 2 minus another log base 2 of 4 is another 2, which is equal to 2. 4 minus 2 does equal 2. So my answer of 4 is correct. In this problem, I'm not starting with a log equation. I'm starting with an exponential equation. It's a very difficult exponential equation because in our last unit on exponential functions, we did not learn how to solve when things didn't really work out so nicely. So what we're going to do to solve this is instead of changing it to an exponential form, because that's already the form it was given in, we're going to change this into log form. So log base 3 of 80 is equal to x plus 5. Remember, the exponent always comes over to the other side of the equal sign. The form change I'm going to have to use would be changing log base 3 of 80 into its change of base, meaning log of 80 divided by log of 3, still equal to x plus 5. We're going to work out what this is with our calculator and then subtract 5 from both sides. I ended up with approximately 3.99, and now it's time to subtract 5 from both sides, and the x I get is approximately negative 1.01. Let's try plugging this into our original problem. 3 to the power of negative 1.01 plus 5, will it equal about 80? Remember, I rounded my negative 1.01, so if I end up with something really close to 80, that's going to be okay. Negative 1.01 plus 5 is 3 to the power of 3.99. And yes, I do end up with something that is approximately 80. So it worked. So this is my correct answer. In our last example, we're going to explore a word problem where we need to develop an equation that we can solve to answer the question. Billy deposits $600 in a savings account at the bank. This savings account receives an interest rate of 3% annually. How many years will it take him to have $900? So let's start to develop this problem. This is a lot like our problems from our last unit on exponential functions. We're going to write an exponential equation to help us solve. So Billy starts out with $600. This gets multiplied by his rate. Remember, when you use percentage rates and we have something that should be increasing, we need to add 100% to our 3. So that would be 1.03 for our rate. This will be to the x power. We want it to end up equaling 900. So now I can use this equation and start to solve it. Let's divide both sides by 600. 1.03 to the x power is now equal to 1.5. I can now solve for this x by changing this form. Log base 1.03 of 1.5 is equal to x. Let's use change of base to solve for the x. I come up with approximately 13.7, but since I want to know in how many years it will take him to have $900 or more, I'm going to just round this up and say that it's going to take 14 years. So you see now we can solve hard exponential problems by changing them into their log form and using change of base. If you have any questions, make sure you write them down or just shoot me a message, a text message, and I can get back to you. Don't forget to answer the questions right after the notes and hit the submit button so I have record of you participating.